Hi, I'm Ilse van der Linden and I am doing my PhD project at the Civic AI Lab. At our lab, we strive to advance society by developing AI that engages and empowers people and communities. For this purpose, we develop and research reliable, inclusive and explainable AI methods. We collaborate with the municipality of Amsterdam on several research projects to co-create AI systems that will benefit citizens in the city and beyond. My research focus is on creating AI-driven systems that will help improve children's well-being. The focus is on overweight and obesity in particular, since overweight and obesity in children leads to chronic well-being problems throughout life. Did you know that almost 1 in 5 children in Amsterdam are overweight? That is almost 1.5 times as much as the national average. In addition, it is known that this is an inequality issue, in that it touches more children in families with a lower socio-economic status and families with a non-Western or migration background. To improve on this, the City of Amsterdam started the Amsterdam Healthy Weight Program. The program's mission is to let all children in the city grow up healthy by 2033. The Amsterdam Healthy Weight Program is trying to achieve their objective through a whole systems approach. This means that the focus is on an integrated approach with involvement of all relevant sectors and actors, such as parents and the children themselves, but also schools, sports organizations, and food suppliers. The program deploys interventions in many directions, from an environmental intervention, such as a ban on marketing unhealthy food to children, to interventions aimed at stimulating individual healthier attitudes towards nutrition or sleep. This program started in 2012 and has achieved a lot in this direction. It stopped marketing of unhealthy products at sporting events. It trained and assigned more than 500 care professionals and 200 health ambassadors. It introduced more than 25,000 children to the Jump In Healthy Lifestyle program. It involved more than 1,200 parents in healthy preschool activities, and it organized over 1,700 consultation hours to promote a healthy lifestyle. The deployed interventions are based as much as possible on knowledge of what works. By monitoring and evaluating the outcomes and learning from these, the program is continuously updated and improved. This whole systems approach provides an opportunity, integrating data from all involved sectors and actors to yield new insights. These insights could offer new action perspectives, allowing, for example, to redirect resources for combating overweight and reducing inequalities with targeted health programs. This opportunity, however, can only be seized with machine learning tools that enable explanations. The trend in machine learning is that techniques are becoming more and more complex and thus less and less interpretable. This makes them more capable for complex real-life applications, yet it greatly limits our understanding of their decision-making process. The more these tools are used for consequential decision-making, the more important it becomes that we understand what their decisions are based on. So we require explanations, but what makes for a good explanation? For this, we look at the way people explain an event. Research shows that people do not explain the causes for an event, but explain the cause of an event relative to some other event that did not occur. This means an explanation of the form why A and not B. We call these contrastive explanations. For example, we will explore how to provide explanations for a system that predicts actions for children and their families to mitigate obesity risk. So imagine that we use an AI system to predict the best course of action for a child that is at risk of obesity. Possible recommendations by the system might include an exercise program, a dietary program, or taking no action. Say, for a particular child, the system recommends a dietary program. An example of a contrastive explanation would answer the question, why does the system recommend a dietary and not an exercise program? For the answer, we can compare this child to children for which the system recommends exercise instead of dietary program. The answer could be that this child gets more physical activity in school hours because their school offers extra PE classes and promotes physical activity during breaks. Research has shown that contrastive explanations help users understand why AI systems make particular errors. However, it also showed that these explanations do not have a significant impact on trust and confidence in the system. This is because the question that remains is, how can I change the outcome? As with the previous example, a contrastive explanation tells us why exercise is the best course of action for a particular child, but it does not show how much exercise will be required to change the outcome and what the result in outcome will be. For this, we need actionable explanations to provide users with a set of actions to undertake to influence the outcome of a system. An actionable explanation could say, if this child would exercise 4 hours a week, the system would recommend no further action. We want to reliably assist health professionals and policymakers in both understanding obesity risks for various population groups and formulating targeted interventions. For this, we need explanations that are both contrastive and actionable. Such explanations enable users to understand how the system reached its decisions and how such outcomes can be changed by influencing actionable variables. So, in our research, we will develop a new method that meets both requirements to generate contrastive, actionable explanations for a variety of machine learning algorithms. This method will be integrated in the data analytics pipeline of the whole systems approach of the City of Amsterdam. We will also develop a novel framework for testing and evaluating the usefulness of actionable explanations on real-world applications. To test these explanations for effectiveness and inclusivity, user studies will be carried out in collaboration with various actors and sectors involved. Moreover, we collaborate in an interdisciplinary team in order to ensure we develop responsible AI that genuinely benefits society.